joined. Those who will still join. Okay, we just cut your mics. Just cut your mic. Anneke, your mic's also on. Right, there we are. Welcome to all of the participants. I think we've got a nice small group. For those who don't know, we've got Kobus van Wijngaard. He's from SAFSEC, and I'm including SAFSEC in many of these things because we share, and I sit on their meetings and they sit on our meetings, so we will start working together. Welcome to all of you. Sorry that I'm only using Kobus as the person I'm mentioning, but I just want to say we also have outside people. Then we've got our companies here. We've got PPC, we've got AfriMat, and so forth and so forth. So welcome to all of you. AfriSam is our chairperson. That's Nolan. I'm handing over to him now. Now they're coming in fast. I think we always just say this because we're the only organization that I am aware of that hasn't been hauled in front of the Competition Commission because we do not share stuff and we've got a code of non-colluding. And then just quickly, the rules of the Microsoft Teams. We ask people to cut their cameras, to cut their mics, and to raise their hands. And those of you who battle with the raising of the hands, we will excuse you because sometimes they go up and then they forget to take them down. So please just look at that little hand and so forth. And then we will keep the discussions short and to the point. Now, my chairperson is Theolan. He's from AfriSam, and most probably, I shouldn't say it too loud, but Theolan is most probably my chairperson who's got the most energy in him, and he's always running around. So he's a star. I don't say this because he's in there, but because he's just a star, and he does his thing and he helps us. Theolan, I'm going to hand over to you. I'm going to cut Mike. I'm going to cut everything, and then if you shout and say, Nico, where are you? I will be down next. Thanks, Theolan. Welcome.
Thank you, Nico. Welcome, everyone, to the first engineering committee meeting for 2021. It's been a tough year last year. I think we ended on a good note with the last engineering committee meeting we had. And hopefully, we get a better crowd this time around going forward. I'd just like to start off to wish you and your families a Happy New Year and all the best for this year. And from an agenda perspective, we're going to be starting off with two presentations on SAP plant maintenance and then on the aggregate plant process. We have a supplier, IMS, who will give us a presentation, Etienne. Then I will just talk about engineer development in the industry and what we are trying to do to try and bring up the members of ASPASA more from a young professional view. I also further like to just ask under relevant engineering issues, we're going to touch on the engineering XR registration and a plea from us just to assist us with some of the professional engineers from your end. If they could just put their hand up or send a mail to ASPASA or myself so that we can just get a few more members to complete the registration, and also volunteers to come forth from a presentation point of view, to help networking from your expertise area. So without further ado, I'd like to hand over to Roshan Singh. He's the maintenance planner for quite some time at AfriSam, and he's going to do a high-level presentation on plant maintenance for us. Rosh?
Hi, good day, team. I must to Nico Pinar, Theolan, and the team, thank you very much for granting me this opportunity. And I hope I, as well as all of you, take something out here, and all the best to every participant in this team. I'm going to put up a presentation called SAP Plant Maintenance. and then we take it from there. I'm just uploading at the moment. So if somebody just gives me the okay that they can see this presentation.
Yes.
Yes, Rosh.
Good. All right. SAP plant maintenance. My name is Roshan Zamir Singh, and I'm very honored to do this presentation. So welcome to plant maintenance.
Sorry, Rosh, can you just put it in presentation format? Thank you. Thank you.
Rosh, it's Nico here. Maybe I forgot to say that this meeting is recorded, and what we will do is we'll put it on YouTube. You go to YouTube and you type in ASPASA, and the guys can get it afterwards, and then you guys can also share it with colleagues in the workplace. Thank you, Rosh. Sorry for that.
Thank you, Nico. All right, so basically we are welcome to plant maintenance, and plant maintenance basically is the lifeblood of any industry. Very important point to remember, if we fail to plan, you plan to fail. So this is what Benjamin Franklin mentioned, and I say a failure to plan is a planned failure. So in the work management framework, the first things that we need or come up is we need to identify work, we need to plan work, schedule it, execute it, and complete the work. So if we look at a SAP plant maintenance flow diagram, and this also, relates to other maintenance systems, the first thing that we have is a notification. It's a and then we create a works order. So notification basically is to notify somebody that there is an issue on the plant, and then a works order actually goes out and see what the issue is, and then it goes over to a purchase requisition stage if we need components, etc., to actually repair this. And then a purchase order is generated. Procurement takes over this function. And when the necessary parts are received, then it is issued to the works order via a goods receipting process. And then the works order is approved. At this stage, then there is meetings that is held as well between production and maintenance, and a suitable time is set to actually perform the task. So the works order gets scheduled and released. The works order gets executed. The artisan goes out, performs the task, and once the task is completed, then he actually reports to his superintendent or team leader. The task is inspected and signed by and then a sign-off process takes place, and then the works order is closed. So there is general types of maintenance philosophies. We have corrective maintenance, preventive maintenance, risk-based maintenance, and condition-based maintenance. For this presentation, we're going to talk about two types of maintenance philosophies, which is corrective and preventive. And most organizations run into corrective and preventive. Corrective maintenance, basically there is two types. One is planned corrective maintenance, and we get the unplanned corrective maintenance. So planned corrective maintenance, what would that be? Corrective maintenance is planned when we run to fail maintenance strategy. This is when an asset is allowed to run until it breaks down and is then repaired or replaced. So to give you an example of that, if you're responding to an emergency request to repair a heating system in the middle of winter, and then you're either notified that or you find out that the HVAC system needs filters to be cleaned or replaced to improve efficiency and to prevent further heat loss. So what would the difference be between planned versus unplanned maintenance? So unplanned maintenance, or rather unplanned corrective maintenance, in unplanned corrective maintenance is unplanned when preventive maintenance is scheduled, is in place, but a breakdown occurs between scheduled maintenance actions. Maintenance can and may be performed immediately or at a later stage, depending on the availability of tools, parts, personnel, etc. So what would the example of an unplanned corrective maintenance be? Let's say there's an industry that has got a forklift, it runs, and this forklift is very strategic to the operation and it has a breakdown. So when this forklift breaks, you get the technician that scrambles to get it working again. This is considered unplanned corrective maintenance. Now you'll notice in our industry, and if we're talking more in manufacturing, quarrying industry, there is so many breakdowns that is unscheduled, and these breakdowns kind of have the same effect where you get the technician scrambling to actually get it running again so that the production line can be operative again. Planned versus unplanned. What is the difference between planned and unplanned? Planned maintenance cannot be reactive. So if we have a PMO2 schedule to actually go and perform a task, then that is planned. We're not reacting to something. We're actually going out there and maintaining something so that we do not have to become reactive. Unplanned maintenance is any maintenance that is not anticipated beforehand. So you got a breakdown, and that is what has happened. It is unexpected and not part of the normal flow of maintenance activities. Unplanned maintenance and reactive maintenance are often used interchangeably. So that is as far as corrective maintenance goes. Preventive maintenance in SAP is regarded as PMO2s. And what is it? So preventive maintenance is the regular and routine maintenance of equipment and assets in order to keep them running and prevent any costly unplanned downtime from unexpected equipment failure. We need to keep in mind as well, while we're talking about preventive maintenance, it must not become a tick box exercise, where you have a schedule, your artisan goes out there, or even if he doesn't go out, tick the boxes. This is just a point of caution that I'm mentioning here. So a good preventative maintenance plan also involves keeping records of past inspections and the servicing of equipment. So basically, a machine history report is very fundamental and required to run a good operation. Within SAP PM documents, within SAP PM documents can be attached to notifications and works orders. So should you have any strategic thing that you need to attach as history to the equipment, then SAP PM works orders and notification can be attached to works orders. So should you have, let's just say, even if it is an invoice that is strategic, you can attach this to a works order or notification, and later on it can actually form history that could be used to take business decisions. If it is expensive maintenance that needs to be carried out, or even asset replacement. So you'll need this type of information to actually form a solid foundation to base your case to replace these equipment or to perform the expensive repair. Preventive maintenance, examples of that. A preventive maintenance schedule may include items such as cleaning, lubrication, oil changes, adjustments, repairs, inspecting and replacing parts, and partial or complete overhaul that is regularly scheduled. The goal of preventative maintenance is to prevent equipment failure before it occurs and to reduce the risk of accidents. So our technicians basically has to go out and use the senses as well. We need to see, we need to touch, we need to feel, we need to hear, and anything like this needs to get reported. So the check is performed against a task list, and in this task list as well, there is some very important requirements and the first thing we need to identify is materials required. What is it that we need to require to actually perform this task or this schedule? We need to record repairs that is completed. So while performing the schedule, you'll notice that we find some things that we can do immediately. And if that is the case, we perform this task and record it, as well as there is some items that we might not be able to repair immediately. So this finding is noted in the PMO2 schedule, and then a notification, etc., is created, and this job is done via corrective maintenance, or later on it can be either done immediately via a PO1 schedule, or it can be scheduled, for example, and done on a maintenance day. Reporting. Reporting is fundamental in order to maintain a healthy culture within SAP, and especially for plant maintenance. Reporting in SAP is done via business warehouse as well. Integrated the SAP production system together with business warehouse, we can get the following reports. Class reporting analysis, where you could put all the screens together and get a download of all the screens in the organization or in the business unit. We could do cost analysis, failure analysis. Failure analysis is very important if we do our notification and feedback correctly. Machine history report. So if you want to know basically what is the status of this machine in terms of it working without any problems or with problems, you hone on to the machine history report, and you can then make important decisions going forth in terms of replacing or expending money on repairs to make the machine more reliable. We can draw out 10 most troublesome unit reports. So basically it tells you, all right, within this date, from a start finish date, which units or equipment gave me the most amount of trouble. And then you actually look at these units and see how is it that I can repair it? What is it that we can make to make it more productive? There is KPI reports that we can draw out of the system, and unit cost reporting. Unit cost reporting is very important. For example, if we have got a string of front-end loaders and you find that we're expending money towards all these front-end loaders, you need to find out which one is the most troublesome and why is it that we're spending all this cash. So unit cost reporting is very, very important. Going forth, should we have a failure, for example, in our organization, any failure 3 hours and above must be subjected to a root cause analysis. So in a root cause analysis, what is it that we have to find? First of all, we need to define the problem. Then we collect data on it, identify possible causal factors, identify the root causes, and then we recommend and implement solutions. This is very, very important. And you've got to have a very good team who is dedicated, to their equipment to actually come in with facts that will help you to perform good root cause analysis. Root cause analysis does not only stop over there. What we then need to do is to see what is it that we need to do to ensure that this failure does not occur again or is minimized. So we get back to the PMO2 task list and we say, all right, now we need to check this particular equipment or this particular sub-assembly often to ensure that there is no failure that leads to a breakdown. And then maintenance of this particular sub-assembly will ensure reliability of that machine and we do not have breakdowns. Very important then going forward is continuous improvement. Within continuous improvement, firstly, we got to build an effective culture. And that is embedded continuous, or rather, the other one is that we as leaders need to embed continuous improvement in the organization's DNA. So building an effective culture and of continuous improvement is not just about executing a cluster of improvement projects. Definitely not. So while, it's a good place to start, we need to actually embed this continuous improvement culture in the organization's DNA. We need to invest in leadership. Good leadership produces good results in plant maintenance. So most organizations have the knowledge of the various continuous improvement tools and principles, but haven't invested in leadership, commitment, and framework that is required to establish a systematic and sustainable management process of improvement. We all talk about Toyota when it comes to good production and a company with good DNA. So Toyota's organizational DNA and culture was created by the Japanese ingenuity over 70 years ago. And believe me, it is still going strong. In all maintenance presentations like this, the name that comes up is Toyota. So why is Toyota so iconic? Toyota basically, follows a systematic approach in ensuring its philosophy of improvements is instilled in every member of the organization. Today, most of our business is lacking in this. We do not instill this continuous improvement culture within every artisan or technician in our organization. And I think this is where we need to start. So we need to nurture and develop the right enabling patterns of behavior. We need to ensure that every person is participant. They understand what is expected of them. So we can't copy and paste culture. Rather, we need to nurture and develop the right enabling patterns of behavior so that, we can achieve continuous improvement. Remember, we as leaders as well, never shoot an idea down, because the person who is coming to you with this idea has got something in mind to improve production or the maintenance of this particular equipment. It is better to have a sit down and slice and dice this so that we can, come up with good continuous improvement plans. Then success in continuous improvement. It comes and boils down to good leadership. If we have good leadership who instills this continuous improvement culture within its artisans and technicians, then this is going to succeed the business, as well as it is going to succeed in continuous improvement. I've listed some of the points that will assist in continuous improvement. As a start, I've put in just 7 important facts here. So we need to lead by example, participate in continuous improvement openly and with enthusiastic and vigorous enjoyment or appreciation. Like I mentioned earlier on, if somebody comes through to you with an idea, remember, he's got a plan, he's got it thought out, and he knows what he's going to put in front of you. So don't shoot him down. Enjoy the moment and make him feel good so that the business can actually succeed. So talk about the importance of continuous improvement with everybody at every opportunity. We have green area meetings every morning. This is a good place to start. Make a general statement. Tell the guys, look at the equipment within your area of responsibility. Come back. Let me know how we can improve this. And by mentioning this over and over and over again to the people, it becomes part of their culture. You consistently ask for ideas for improvement and respond quickly to those ideas. If a guy comes through, or if a technician or artisan comes through with an idea, it must not be that I'm very busy now, I kind of look at it and get back to you after 3 months. So no, you don't do that, So you act upon it very, very quickly. You empower employees to make daily continuous improvement a part of their own work. And I mentioned green areas. That's a good place to start as well. But other organizations will start maybe in meetings or wherever. So if you're taking this back, it's a very strong point. Don't only ask for ideas that directly affect the bottom line or meet a certain return on investment criteria. No, there could be something small that causes a breakdown, and then you're going to lose production time. Loss of production time is loss of money or return on investment to the organization. In a business unit, be it only in South Africa or be it international, you need to help share and spread these ideas, because it is good, solid ideas that has been taught. It is ideas that is working in an operation, hence it needs to get shared. So document and celebrate the results achieved through continuous improvement. In our organization, we have a thing called high five, where a high five is presented to the employee. And not only that, it is also followed up by a personal call. It is mentioned in group meetings where the individual feels nice and he feels that he has made a positive contribution. And this type of behavior also has an effect on other employees, where they want to better what has been done so that they could also achieve these accolades. So yeah, that's celebrate this. Very important.
Rosh, sorry, I think we're not going to have time to run through that presentation.
I'm almost finished if I get the next 2 minutes.
Okay, no, it's fine.
All right, so the final one is that we must not fight these battles, on our own and take on our artisans or our technicians, because this is what is going to happen if we do such a thing.
Rosh, nothing is happening on the screen?
So Theo, this basically is the end of the presentation.
Okay.
Nico, Theo, and the team, I thank you very much for this opportunity.
Yeah, thank you, Rosh. But you can obviously circulate this at the end if you don't mind. And thanks for the presentation. That's Roshan Singh with over 35 years of experience, and thank you for that. Okay, we're moving along. We're going to just jump item 4 with the relevant engineering issues, which I'll tackle at the end. We've got Padima Ledwaba from FECM, and he's going to give us an outlay on the aggregate plant processing optimization. Padima, over to you.
Okay, thank you very much, Theo, for the platform. I'll just be uploading my presentation. I just need a heads up if everyone can see it. Is it fine?
Yes.
Yes, it's fine. It's been in presentation format, Padima.
Okay, definitely. Is that proper?
Yes, perfect.
Okay, thank you. My name is Padima Ledwaba. I'm a junior engineer at ASPASA Construction Materials. Today, I'll be presenting the aggregate plant process optimization. The presentation outline is divided into 4 sections. 1 being, what is plant optimization? 2, why is plant optimization required in aggregate processing plants? 3, the thinking behind plant optimization. And 4, a trade-off analysis, which will form as an example of plant optimization process. What is plant optimization? Plant optimization is a decision-making process to utilize available resources. This may involve maximizing the plant system through changing process settings. These process settings may be, for instance, changing screen panels or changing close-eye settings in order to maybe achieve increasing a throughput. Another way of plant optimization, you can utilize funds to perhaps initiate an optimization project. This project might be maybe changing an equipment to increase your availability at a plant. This type of thinking allows industrial applications to continuously improve their operation. For example, increasing material throughput through changing their equipment at a plant, or to maintain a plant feeds through installation of supervisory controls or any regulatory control. Number two, it increases competitiveness in the market. For example, you minimize resource consumption through decreasing, you minimize resource consumption to decrease your product pricing. And it also helps you to conduct trade-off analysis. This just implies that you lose one aspect of the business to gain another. Why is plant optimization required in aggregate plants? Aggregate plants involve energy-intensive methods for handling volumes, and it also suffers a vast scale of variables during processing. Both of these points actually need minimizing. For instance, point number one, you can minimize energy-intensive methods through initiating perhaps decreasing diesel consumption through utilization of a more efficient EME. The second point, you can decrease these variabilities by installation of a supervisory control or a supervisory control or a manual control. This type of controls would be your normal level sensors. This is specifically an example of supervisory control would be a level sensor that ensures that your plant is or your crusher is crushing at a correct level. Typical driving elements for plant optimization include technical functions. This would be driven by installing an equipment that increases throughput, or an economic function. Here would be driven by things such as meeting the product demand or the market demand, or decreasing diesel consumptions to save a bit more of costs in your operation. The third one would be an environmental function. This type would be where maybe you have an environmental issue of contaminating your public water. So there's certain projects that need to be initiated to decrease this, or perhaps you've been prompted to decrease dust emissions. The thinking behind plant optimization is to develop a universal approach which will make it easier to optimize areas of interest. Research in optimization systems in comminution, which is basically a breaking and selection of material, is shown to have benefits in this application, such as, for instance, research which was done in crusher liners. Here, we try to maximize liner utilization. At the present moment, we are working on a project where, on one of our plants, to ensure that we do maximize utilization of these liners, instead of just throwing away a liner that's been used almost 20% of it. So we try to use at least a maximum 50% and so forth. The second bullet would be crusher sequence optimization. This is where we use certain programs to help us select the correct machine for a specific application. And the third benefit would be to develop proper instrumentations that can help us with running our plants and feeding them in a more of a, I'd say, a set feed to the plant instead of having too many variables. The presented concept of the thinking of this plant optimization was actually adopted from Badani's article titled Optimization Framework for Crushing Plants. So this is the concept that was derived from that article. The thinking of optimization. This is a decision-making process in optimization. It involves 3 steps, which are iterative in nature. The first one would be optimization system. This is the thinking behind enhancing a system capabilities. It is more of a goal-orientated type of thinking. So one would say we have a problem, or we have an initiative of perhaps increasing the throughput of a plant. So this system is fed by both the performance measuring system and the comminution and classification system. The performance measuring system and comminution classifications actually talk to one another, and thereafter feeds to the optimization system go. So the performance measuring system would be where we actually get data to realize and evaluate the initiatives. This type of data or KPIs would be OEEs that we get from our plants, or operation cost, where we look into things where we can perhaps decrease costs by doing any project that will help with this regard. Communication and classification. This system involves crushing and screening processes, which feeds the KPI. The function can be expressed in a physical system or a simulation environment. A physical system would be your plant as is, which is your crushers and your screens and conveyors. Whereas a simulation, it's where you actually simulate the process through utilization of a program. The flow chart here is an overview of the development of the optimization system. It is divided into two, being the concept building. That entails defining scope of optimization, application, and also simulation models configuration. Defining scope of optimization application. Here we ask questions such as, what is the main focus? Do you want to increase product throughput? Do you want to decrease cost, and so forth? From this, we also ask questions like, which model do we actually follow? Do we follow maybe installing an equipment to increase throughput, or do we change the entire process? Simulation models configuration. Here we utilize computer programs to simulate an actual process. Programs may be a steady state nature or a dynamic nature. A steady state nature program would be one of those, such as Bruno and Airflow. These programs actually captures the instantaneous mass balance of the plant process. But then by putting it that way, it's actually accepted in project processes. But then another one is your dynamic nature. Here we capture time varying processes, such as looking at what wear rates can influence on the product throughput. The second part of this flow chart, it's basically the execution and evaluation phase. It is entails of optimization methods that are selected, optimization problems definition, one factor at a time study, optimization methods implementation and execution, and lastly, optimization solutions evaluation. Optimization method selections, so it's divided into two. There's a single objective optimization, and number two, it's a multi-domain optimization. A single objective optimization, it's when you look at one aspect, and then this aspect, once you change it, it's not necessarily going to change everything in your plant. So an example would be, let's just say you want to decrease the pricing of or the cost of your electricity. One would just install a power correction factor if it's not available at the plant. So installing this thing or this equipment does not really change how your plant works. And then the second one, the multi-domain optimization here, it's a point where once you change one side of your plant, you tend to change cascading plants further. So for instance, you will change maybe a close setting on maybe your primary plant, or change your screen medias on a primary plant, and then it turns out this actually affects what's happened, the performance of cascading plants like your secondary. So you will have to go there and also make necessary changes. Optimization problems definition. Here we enlist the requirements of objective functions. For example, in order to increase your throughput, maybe you'll require to change your close site settings on your crusher, or you have to change your screen medias just to get that the scope or the initiative. The one factor at a time study. Here we use to evaluate the behavior of the objective through changing variables one at a time. So if, for instance, you have your primary crusher, okay, I'll just work on a secondary because that's a project you're currently working on. So for instance, instead of now changing your panels at the same time as you change your panels, you change your close site settings at the same time, you can't really determine what caused your whatever that's happening at a downstream. So instead, perhaps you just start with, let's change the panels. Let's see how the plant behaves. When that's done, you get the data down. And then after that, okay, this is fine. Let's move on to changing the close site setting. When that's done, at least now you have more concise information of your changes. The optimization method implementation and execution is basically where we coordinate the concept which was realized in the first beginning stages. To evaluate the process or the initiative, there's two types of analysis. So the first one is convergence analysis, and the second one is your physical analysis. So the convergence analysis, here we determine an optimum point. For instance, you've been making changes, so it talks more to your one factor at a time study. So you've been changing your panels, and then you see all these changes. Or you've been changing your close site setting, and you see all these increase in throughput. But then now it helps you to get the optimum point of, for example, your close site setting. Instead of going to 50, where you end up decreasing performance on a downstream plant, let's just stick to a 30. 30 works fine for us. So this is what convergence analysis helps us with. The physical analysis actually looks at the concept feasibility. For example, are our operating cost increased due to wear rate as we changed our close site settings? Just to give an example of the flow chart which was discussed previously, there was a trade-off analysis which I was tasked to execute at one of our plants. So as per the flow chart in the previous slides, we did define a scope of optimization or a problem statement. Here, the plant was required to increase the production of its 9.5 millimeter stone. The method which was followed was obviously we configured a simulation model. Here we used the Bruno program to simulate the increase of this product. And then from that, Bruno, we actually took actual data of the product which we have been producing previously. We took that data and compared it with what was on Bruno. So it will help us with this comparison. Actually helped us with actually seeing if we can go on with this initiative. So we did proceed with the initiative. So the optimization method which was selected was a more of a single objective optimization method. Here we worked on one screen. So it was a product screen. The main focus obviously was to increase the 9.5 stone. But as I did mention in the first slide, a trade-off analysis, you lose one aspect of the business to gain another. So what had happened here on, I'll just explain how we did that. The optimization problem definition, here we listed requirements. These requirements is basically we have to lose the 6.7 millimeter stone to gain more of the 9.5 millimeter stone. One-time factor analysis. One factor at a time study which was done. What we did, we actually blended the middle deck because as mentioned, it was a triple deck screen. We changed the middle deck to increase the throughput. As soon as we saw that, okay, the throughput is working, we started testing the material or the product which we were getting. So we saw, okay, we changed the middle deck, the throughput does increase. And then after that, we saw that after testing the product was became a bit more fine. So we moved on to the next step where we actually worked on the top deck to try control the quality. So by doing so, this was actually the product was actually reached to our specification. The optimization solutions evaluation. Here we did the convergence analysis and both the physical analysis. The convergence analysis helps us to determine the right number of panels that were installed on the top deck and the right number of panels which were installed on the middle deck. And then lastly, the physical analysis. So we saw, what we found out from this project was that the rate of the middle deck panels had increased. So the wear rate, it increased. So we were changing the panels more than regular. However, the benefits of getting that 9.5, because it was in demand, outweighed the cost of changing the panels. Then this comes to the end of the presentation. If there's any questions, you can ask me. Thank you.
Okay, thank you, Padima, for your area. We'd like to move on now to an external supplier, IMS, Etienne Swanepoel, NMO, to give us their presentation.
Thank you, Theolin. I just want to start by thanking ASPASA for granting us the opportunity to present our technology to you guys. Joining me today is Ryan York. He's our Hazamak product sales manager, and Emil Worth, which is our Kawasaki product sales manager, he will take us through the presentation today. And I think this ties in nicely with what Padima was presenting.
Yep. So,
Thanks for that. Padima, can you take your slides off? Okay.
Okay, give me a second.
all right, I'm just going to share my screen quickly. Don't mind just telling me if you can see that.
That's fine,
Yes.
right?
Good. Okay, I'm going to just go into the presentation mode. Okay, gentlemen and ladies, like Etienne said, thank you very much for this opportunity. We want to talk to you guys a little bit this morning about why we believe you can improve your crushing circuit performance by using the Kawasaki Cybers iCone crusher in your circuit, and we will talk a little bit about specific features that the crushers have that make them different from the competitors' crushers. Okay, IMS Engineering is a comminution solutions provider, and we can offer a wide range of comminution and process equipment, but for the purpose of this and the time allowed, I'm going to just focus on the red highlighted area, which is the compression crushers, and specifically the range of Cybers iCone crushers. The cone crusher, the Cybers I, as it's called at the moment, that is already the 5th generation of cone crusher that has been developed and improved through research, etc., over the last 70 odd years by between ourselves and a company called ETCL in Japan, and we have got a cooperation with them, and this includes licensing agreements, manufacturing agreements, and even joint venture agreements depending on the type of project we're working on. This means obviously that we can do either local or global manufacturing, but the cone crushers that's under discussion today, that is 100% locally manufactured with obviously some global procurement as required. And just as a point of interest, we've been this association has been going on for about 3 years now, so it's not just since last week basically that we've been involved with them. Okay, the cone crusher. So typically your these crushers can be used in a secondary or a tertiary application, or even a quaternary application, sorry. And I mean, depending on what model you use or what gap setting you run at, I mean, you can process from as little as about 50, 60 odd tons up to in excess of 1,000 tons now, depending, like I said, purely on what you use. And although these crushers are normally used and offered in a dry application, depending on when you have some sticky, wet clay material, we can also offer it as a wet system, where we will obviously install some water jackets inside the crusher to just assist with the flow of material through the crusher, and thereby not decreasing the throughput as much as when you try and do it a wet application with a dry crusher. Sorry. Just a very, very basic breakdown of the major components. You've got your hopper, your top frame assembly, bottom frame assembly, the main shaft, and obviously your hydraulic cylinder. I'm not going to spend too much time on this. I believe most of you know, or all of you will know, the basic breakdown of a cone crusher. So I would rather move on and discuss some of the features that we've got on these crushers. And starting off with the first point, the Kawasaki cone crusher is a hydro set design, i.e. the main shaft is supported by a hydraulic cylinder, which means that that will move the main shaft up and down to change your gap setting, to do tramp relief, and to do during continuous monitoring during the operation. This obviously makes the crusher very flexible. If you compare it, for example, to a typical your bowl type crusher, where you make use of the hydraulic cylinders to turn the bowl to increase the gap or decrease the gap. it's much faster, and it can obviously also be done remotely if you by using the hydroset design. The three main features that basically sets us apart from the competitor crusher is that I'm going to go through and discuss a little bit more detail in the next slide. Is first of all is the spherical bearing design, our patented MSI liners, as well as the crushing chamber design in the Kawasaki crusher. And you can see obviously there's a little bit of a summary of the benefits that you've got. I mean, it's energy saving, high set under, product shape, wear profile, etc. We'll go a little bit into more detail as we move through the various features. So starting off with the spherical bearing, the Kawasaki crusher, the Cybus I crusher, instead of having your typical traditional spider bush, it makes use of a spherical bearing in the spider, and as you can see in the little illustration there. And obviously the advantage of that, as I think once again clearly illustrated in the little drawings, is obviously with a spherical bush, your contact area or your load receiving area, if you, what you want to call it, is much bigger with the bush, with the spherical bearing than with the bush. And this, in the end of the day, leads to you've got an extended component life, your machine is more readily available, and if you want to talk cost, obviously it will reduce your OPEX, because I mean there's less chance of failure on the spherical bearing than with a crusher that's got the spider bush in. As far as my knowledge goes, we have never lost the spherical bearing actually on any of our cone crushers to date in the last 30 odd years since since we started with this. And maybe a point right at the bottom, I see it's there, is it's something that's not purely mechanical. Also from a process point of view, this by using the spherical bearing, you've got more eccentric movement in the upper region of your crushing chamber, which allows you to crush large rocks relatively high up in the chamber and doesn't have to come down and fall down before it gets nipped and then gets crushed. So a little bit of a process advantage obviously as well for that. The next feature that sets us apart is we've got a curved crushing chamber. Most of the other competitors have got what we call the linear type. If you look at the little illustration on the top there, basically it's got flat sides, your mantle and your concave. But I'm not too sure if it's very clear in the picture, but normally what happens with that is you tend to get a concentration of the material towards the lower end of the crusher, which a lot of the crushing takes place. So it's high point loads on the material at that specific point, compared to the curved type where it's normally a much more even distribution of the material. So you literally start, as I mentioned earlier as well, you start crushing higher in the chamber. So what this means is you've got high crushing forces, but not at a specific point, more evenly distributed. And this obviously means that we've got a much higher set under. What I mean by set under is that is the percentage product that passes your crushing setting in a crusher setting in one pass. Also, on top of the having the nice high set under is obviously in terms of the liner utilization, it's much better. And I believe the next little illustration will show that. You can see on the linear type, purely because of the concentrated feed in the bottom end of the chamber, you get obviously the wear concentrated in that area, where with the curve you've got a little bit more even wear. What this means obviously is higher. You've got longer utilization on your liner parts, your mantle and your concave. So instead of maybe having 25% utilization or 30%, you've got 35-40% utilization. And also because it wears more evenly, it's much easier to control your gap. So you can have if you set your crusher at 20 mils, as it wears and you obviously lift your main shaft, you can maintain that 20 mil gap setting, for example. So it's just much easier than with when it's unevenly worn like in a linear type chamber. Then the third feature, which is maybe most probably the one of the most important ones, is the so-called MSI liners, the material specific inserts that we put in our liners of the Cybus I crusher. Maybe just to start off making a point, and that is that typically our liners, mantle and concave liners, will come with grooves, as you can see in the little picture there, that the shows without the inserts. But we can also do the smooth liners. We've just through test work, etc., we've over the years and even in actual installations, we've established that there's a significant improvement by making use of a groove liner instead of a smooth liner. So and how did we come about with this? Was it just one morning we woke up? No. Once again, a lot of test work, lot of design went into this, and I think that's what I'm trying to show on the left-hand side. The illustration is we started off with obviously 2 smooth plates, doing test work and playing around until where we now, several years later, with the groove design, where the grooves are misaligned, as it shows there. That's just a very simple design, but basically just to show the idea of how the mantle and the concave will work together when the material flows through the crusher. Okay, so and the nice thing about that is with your smooth liners, you'll get, in a conventional crusher, you'll get compression action. The two will press one against one another. But because of the grooves, you induce a little bit of bending and shearing, etc. As the sorry, as the illustration shows, so the bottom illustration on the slide there. And at the end of the day, all this boils down to that obviously you save energy. It's just because the rock breaks down much easier. Even more important is the nipping ability, because sometimes, specifically if the crusher is not choke fed and it's just, not the material tend to ride around, but because of the grooves, that material, the single material, and specifically round pebbles, gets nipped and pulled through the crusher. So obviously you don't lose any throughput or any how can I call it, inefficiency on the crusher basically. As I mentioned earlier, the set under, as I explained, typically we sit between 85 and 90% material passing the crusher setting in one pass, purely because of the liner design. And then obviously, sorry, what this also boils down to is because of that bending and shearing forces, we tend to produce a whole lot less flat material, from the flakiness index, compared to a crusher which has got the smooth liners and the flat side. So the combination of obviously your curved chamber plus the liners produces that more cubical shaped product that comes out of the crusher at the end of the day. Also, just as a point of interest, we've done test work and we've proved on site that in typical aggregate applications, we once again, like I mentioned, if you combine the effect of the liner and the shape of the chamber, we can get in excess of about 15% more liner life on these crushers, just purely because of sorry, these advantages. Those pictures, just like I mentioned earlier, just shows you we can actually offer a smooth, but purely because of all the advantages, we will offer typically what's shown on the top right, the mantle in yellow with the grooves and the concave in red, orange. And it's also a question of, yes, it's now been done, now we stand still. No, we don't. We actually continuously keep on improving this, and I think the small is maybe not so clear on yours. I'm not showing the screen. The bottom right picture actually shows something that we've done for a Kimberlite customer very recently, where they needed some additional inserts in the parallel zone to try and improve. They tried to reach a specific set under, and by doing that, we actually managed to improve the crusher product even further. So this is it's a process that goes on. I mean, it's not that we leave it, we've now done it, so thank you very much. The slide here just shows basically how this works. I mean, so essentially we've got a groove, we then fill the groove with the insert, as in the picture on the top left. So in a way, yes, you start off with a smooth liner, but because the insert material is softer than the actual liner material, it will wear faster, and then as it wears in, and you can see the various pictures, wears in, partially worn, it goes. So you've got that consistent groove right through the liner life. You'll always have a groove. Basically, that's what I'm trying to say. Up until obviously a point you get where the insert is completely worn out, and which is then also obviously quite a nice indication to say, listen, guys, we now need to change these liners, otherwise, you know, we might incur some damage. So, and very important as well, we've had quite a number of fights on sites over the years. That people, we've got a range of these liners, concaves and mantles, from super fine right up to coarse. And you tend to, or not tend, but you do get the odd guy that tries to take a chance, and he says, but I can get some more life if I make the concave coarse and the mantle medium, etc., etc. It's a match set. It goes together. So if you go for a coarse concave, you have to go for a coarse mantle, because it all boils down to what feed size you can accept and what gap you want to run at, and then getting the optimum out of the crusher. And no, you don't score by having longer liner life by putting a different type liner which doesn't match. You actually get the worse from a wear point of view, to be honest. That maybe is one of I'm getting close to the end now. So as I explained, we've got what we believe a very good crusher with some very special features in it. But we go a little bit further than that. So now we can even optimize this crusher even more. So even after it's you know, delivered to a customer, we then take a little bit further, and we play around by for example, for the specific application. For example, as it's shown there in a kimberlite application to minimize diamond damage. Or I mean, in your application, maximizing the cubical product, trying to reduce the amount of flats, you know, that actually goes through this crusher. So, and how do we do this? We do this through test work, because we believe by doing the test work, we can prove that we've got the right solution for your application, first of all, and we literally try to match the machine with the material, so that at the end of the day, we can provide solid process guarantees. And once again, as a point of interest, most of our orders have got some test work involved during some stage of the project, and we understand it's not always possible to get samples. But for that, we've over the years obviously built up quite a reference base and a database from test work and from site data, etc. So if it's not possible to do test work, we can still select the crusher with, I would say, 95% accuracy at least. So in conclusion, just very quickly, some auxiliary equipment that we offer or can offer with the CyberSi cone crushers. First of all is obviously the like I mentioned right near the beginning, is the automation and control. Because of the hydraulic supported crusher, it's very easy to automate this crusher through a local PLC, but in most cases, actually in installation, it will be linked into the plant PLC, where the plant operator will then sit in his control room and do all the monitoring and even some adjustments, like the setting, for example, remotely. The loop and hydraulic unit that we've got is we've redesigned it over the years, and we've got it down to a nice compact modular design at the moment, which you can then obviously install in a lubrication room if you've got a dedicated lubrication room, or we can also do it, we can containerize it with, and these containers are basically not 100%, but very close to MCC container type spec, meaning it's dust free, cooled, etc. So you can go and put it down in the middle of, I don't know, desert, bush, with your crusher, and it will work very efficiently in doing its job, the loop unit. Another piece of, maybe not a piece of auxiliary equipment as such, but it is a condition monitoring system called IMOS that IMS can offer with the crusher, the cone crushers, actually with any of our crushers for that matter. And basically what this is a continuous conditioning monitoring that takes place around the crusher on relevant parameters, whatever you wanna monitor, for example, oil temperature, bearing temperature, even your liner life, you can measure through this, and all that this does is it gives you the chance to be a little bit proactive to predict a possible failure that might happen, or even, you know, predict your how can I call it, your liner consumption. So, and make sure that you've got stock on hand should it be required to replace. So, and I believe, yeah, that in a nutshell is me. Thank you very much again for the opportunity. I don't know if there's any questions at this stage.
Thank you for that presentation, Emil, Ryan, and Etienne. I think if there's any questions, maybe at the end, if you can use the chat to type in some questions. Alternatively, just pass it through ASPASA and we can get that through to IMS. Thank you very much for that.
Perfect.
Pleasure.
Thanks for the opportunity.
Okay. Okay, so I think it's on my end now. I just thought we'll introduce development for the youngsters in. And I've just put together a short presentation in terms of development in the industry for our engineers. Okay. Okay, so just an overview. What I've looked at is that the construction industry has led to a decline in the commitment of skilled engineering professionals to pursue a career in South Africa. Very important statement to be made, and I think that hasn't been just occurring from 2009, but there's been a gradual decline for quite a few years. And obviously, COVID has exacerbated the effects and really put us on the edge. So it is critical that organizations focus on skills development to attract and retain talent employees, even though we are experiencing tough conditions in the market. So strategic alignment of development practices and processes are fundamental factors in order to build and support the success of the programs and other initiatives. Coaching and mentoring work hand in hand to drive candidates for their short and long-term goals. So this overview basically is more from a process point of view, and I will be touching on strategy on the 17th of February, where we'll look at the talent perspective. So just in a nutshell, if some of us do not know, the Skills Development Levy Act, which basically requires that employees with an annual payroll of 500,000 or more pay a development levy, SDL, of 1% of their payroll. So what happens, I've just pulled this out from the service CETA's website, but what they say over there is that 1% that is paid would go to SARS, and SARS would reevaluate and send that money 80% to the CETAs and 20% to your National Skill Fund. So just on the left-hand side, that 80% is broken down, as you can see, 20% for mandatory grants, just over 10% for the various admin costs, and just under 50% for the discretionary grants. So mandatory grant is basically issued when you have a submitted workplace skills plan. Right, and that includes all your company courses, etc. That needs to be submitted at a specific time in the year and approved from the CETA, and you need to obey to that in order to get up to 20% of that amount. Then on the discretionary sides, those are more in line with your learnerships, your bursaries, and they use a thing called, you can see in small, they're pivotal. So it's your professional, vocabulary, your academic learning sector, and that's mainly for us rotates around your learnership and EIT, engineering training programs and bursa programs. So the 20% for the National Skills Fund, that goes in where there's a specific structure that's put in place where you develop people. The company takes so many people, and based on how that program is put in place, you would be able to claim up to a specific amount. Okay. Then from an engineering perspective, so I'm looking in terms of the registered organizations in ASPASA. So we predominantly look at, and not limited to, electrical and electronic engineers, mechanical engineers, structural and civil, mining, and government certified engineers. So the qualifications that I've looked at, and this is post 1980, on a technician's level, we have the N4 to N6. We have the National Technical Diploma, the Advanced Certified Engineering Diploma, the National Diploma, Higher National Diploma, and the DipEng Tech. So that's the more later one. From a technologist level, we look at the BTech, which is being phased out, and now with the new advanced DipTech and the BEng Tech degrees that have come in place. And from an engineers level or universities levels, we look at the BEng, the BSc, and the newly MEng Tech qualification, which is a combination of the BEng Tech plus your honors. Okay, so looking at some of the career path positions, just put, and again, not limited to, these engineers reside and have access to support functions where they move up various engineering level positions. They could be specialist or generalized engineering functions, and look at analyst positions. From an operational perspective, they can work up to supervisors, works managers, and general management levels. And then from a consulting perspective, they can branch out into professional engineering services and then business development, which is key due to their analytic incorporation. So then from a coaching and mentoring side, I thought this was important because when we look at this year, a lot of our systems and processes fail because the one area from a coaching and mentorship is either that the people that we have don't want to do it, or they don't have the skills the training in order to exemplify what's required at that level. So from a coach's job, just in a simple summary way, it's more on the job short-term phase plan, and it's subject matter specialist, it's hands-on training, and it's the use of theory for practical applications. From a mentorship point of view, it's more of the job long-term focus, supports the growth and development and direction for intended achievement. Now the triangle on the right, and I'll try to use something simple that most of us use, is that Maslow's hierarchy of needs. And basically, Abraham Maslow was a motivation theory specialist. And he developed this where he believed motivation was a result of these basic needs. If you start off from the bottom, moving up, it's a psychological need, the safety need, the social need, esteem, and self-actualization. So what I did was I just tried to find the easier triangle to focus more from organizational perspective, which is the right-hand side. So from a psychological need, every employee will obviously need to satisfy the pay area. Now, once they get that sorted out, they move up the next hierarchy, which is on the safety area, where they want to take care of their families, make sure they have pension funds and all of those good things. And once they satisfy that need, they move up to the social needs section. From the social needs section, that's a sense of belongingness, where they want to make sure that they're good with their friends, their management, etc. When that is satisfied, they move up to their esteem needs, where they want to now internally satisfy themselves. So look, I'm an engineering manager, I'm an engineer, and they're proud of their titles, etc. And when that phase is over and they realize they satisfy that, what Maslow believes is the self-actualization needs is one where you start giving back. You want to take on more responsibilities. You want to do coaching and mentorship and all of those good things. So bringing that back up to coaching and mentorship, what I put on the bottom there is a mentee is more likely to develop a better career path if the interactions with their mentors is holistic. Now, if you bring that back to the Maslow hierarchy of needs, always remember that when you're coaching and mentoring, that you put the individual's needs at hand and try and support them as best as possible, and going through the various levels with them to try and get them to a stage of self-actualization. Okay, then from a development of operational specific programs. So in order to do this, obviously strategy is what needs to be incorporated first. But from a program development point of view, most of our quarries can add in these specific modules. Obviously, it will change from business unit to business unit, but we usually have electrical modules where we'll cover substations and MCC layouts, electrical infrastructure calculations and selections, protection systems. Then from a mechanical module, equipment component and specifications, tolerances, process flow studies, mechanical equipment calculation and selection, hydraulic, pneumatic, and lubrication studies. Then moving to the maintenance modules, critical and ancillary equipment, maintenance systems, processes, and schedules, preventative and predictive studies. Then from a safety and legal aspect, some of them are lockout procedures and risk management protocols, legal registers. Then from a project management area, from your project cycle scheduling, project tracking tools, risk mitigations, and so on. And then your mining manual modules, including quarry geology and mining principles, your blasting principles, and load and oil management, environmental rehabilitation. To sum that up, the program should be to best practices and where possible be a gateway to improve the pathway to your GCC Annex to E requirements, your professional registration with EXA, and your professional project and construction management modules. The program task should allow for theoretic learning and applications thereof at the correct level. The task complexity outcomes should be adjusted to discipline-specific area candidates. So that I mean is you can use a generic model, but the level of complexity will differ from a mechanical to electrical. For example, you're not going to ask a mechanical engineer now to do fault level calculations for the MCC substation. And obviously, electrical personnel or discipline will need to know how to do that. One will understand and one will need how to do that. Then from an external training, it should be provided to gain knowledge on specialist equipment or processes. Also, CPD points through supplier-specific discipline training are required to keep up the professional statuses. Programs should be focused on creating a culture that accommodates and supports diversity of workforce in order for employees to feel a sense of acceptance and belongings to avoid feelings of isolation. So in that area, and we'll discuss it more on the 17th of February, but I'm bringing in organizational culture and development as well as psychological contract on there. So just in a nutshell, development success. We need to be strategic. It needs to be a strategic part of business objectives. A standard practices and processes needs to be devised. A program supporting a process must be defined. Leadership needs to support the portfolio, and stakeholder clarity needs to define roles and responsibilities. It needs to provide the relevant ongoing training for management relating to coaching and mentoring. All stakeholders are accountable for specific outcomes of the process. A very key one, that. And engineering being developed should take initiative to drive the process in order to schedule the feedback, track the progress, agree on the tasks, work efficiently and effectively to make required task objective for sign-off. So in our industry, obviously, it's very difficult for us to babysit and have a structured program. So how we usually run these programs is it's also the initiative of the person that is being trained in order to take initiative of this to make this work. Further than just other stakeholders like HR and the management teams and the supervisor teams to be involved, always believe that the strongest candidates that come out through these programs are the ones that take the initiative on their own. And lastly, ongoing monitoring and feedback measurements to determine alterations required for the success of the process. So you've got to measure how your program runs and if it's you're reaping the benefits from it. Okay, the meeting on the 17th will also give you an insight on how to develop these programs, these processes from a strategic level. And it doesn't cost you an arm and a leg in order to get this thing going. So I urge all of you all who can make it for that meeting to be a part of that and join us in that. Okay, thank you very much. Okay, so we come up to the last section, which is the relevant engineering issues or concerns. So maybe if I can just start off. So I did mention that the young professionals meeting will occur on the 17th. So if you all can diarize that, and if you all do not have access to the meeting, if you could please send ASPASA an email. Then there's calls for presentations from suppliers and from other companies under ASPASA. If you could please send us some topics that you would like to discuss. Also, what we're going to be requesting going forward is some mentorship opportunities. So there's a lot of white heads around the table, or some of us would know it. But Waikos have got a lot of experience in the industry, and I would appreciate, we would be sending an email to you all to help with our youngsters and some of our personnel that want to be developed from a mentor point of view, if you all can partake in terms of that. And lastly, from my side, with the XR registration, so where we sit currently is we have approximately 6 people that have responded, that have registered with XR as on a professional status. There are quite a few more, however, we have not received any responses from those people. If I could just urge you or take it back to your companies, if there are any XR registered personnel, not candidates, but professionally registered, if you can please respond to ASPASA or myself with your number, and it needs to be active. In other words, you'll need to be in good standing with XR so that we can complete the voluntary association process and get ASPASA on the map with XR. Okay, coming to that, can I just open the floor to any questions from all of you? Okay, I take it that there's no questions. Okay, so on that note, Nico, can I hand it back over to yourself? Thank you everyone for joining us. It's much appreciated for your support, and hopefully we can grow from strength to strength from the next meeting onwards.
Thanks, Alan.
Sorry,
Warren?
sorry, Nico. Sorry to interrupt.
Yes, Warren.
Yeah, just coming back to your last request there, I'll be happy to assist in that regard. I've also tried to engage with EXA to get a agreement and commitment and undertaking going this side as well. We just aren't having good response from EXA. I think things are a bit dear macaw that side, but I'll be happy to assist you.
Yeah, well, I didn't know which Warren I was talking about, but now that's welcome, Warren. No problem, Warren. So then if you can just send me an email with your registration number as well. And if you need help with XR, you can just pop me a mail in the back and I can try and assist you as well.
Perfect. Thanks, Darren.
Thanks, Warren.
Warren, where are you from? Sorry.
Originally from Theolin's team, but across at Lafarge, Nico.
Ah, okay, sorry. Yeah, there's so many people with the same names. Only me have got Nico. So, Warren, thanks for that help. Yes, we're battling. I just spoke to Paula now. We're having a problem that there are people in companies that are registered engineers with EXA, but we're not getting their names, and we need 10. So it's quite urgent. I sent out a thing a while ago asking, but I don't think people read it. So please, guys, help. Then we can register it. Everything has been submitted. We just need 10 paid up engineered people with EXA. Then they will click it off and we're in. But yo, it's a problem. Thanks.
Yeah,
sorry, Warren.
Sorry, Nico. I think on that regard, Mark Robbie from Lafarge, he's been forwarding me all the information. So there's probably just a mix-up with my email address. So I haven't been receiving anything from from ASPASA. So that will obviously change once you get my details as well.
Yeah, please drop me a mail, Nico at ASPASA, and then we'll load you. Yeah. Thanks, Wally.
Perfect.
Thanks. And thanks to everybody else who joined. If there's one more or two more questions, quickly throw them in. Otherwise, I see my recording says time is up. I just must say, Theolan, thank you very, very much. And we can, if there's papers that people want to present, we can have an interim presentation system or a session. We arrange our own meetings, so don't worry. If there's 3 or 4 very interesting, worthwhile papers, send me a mail. We set it up. I'll speak to Theolan, and we have a short hour and a half presentation thing. There's many things happening that we're just not keeping up to all of it. So thanks for that. And yeah, I think that's the end of it. There is a date set for the next meeting, which are not with me, but we will send it out again. So get your names to us so that we can make sure that you get the invite. Otherwise, we shall close down.
Thanks, everyone.
Thank you very much. Okay, bye-bye.
Thank you.
Thank you.
Bye.
Thank you. Bye-bye. Thank you. Bye-bye.